All right, let's do homework number 6. Not too many people were having trouble with number 1. Local ski sale features 8 types of skis, 6 types of binding, 7 types of boots. You have to find how many packages there are available when you combine those. So each one you have to multiply by each other. So 8 types of skis multiplied by 6 types of bindings multiplied by 7 types of boots. So what we have to say is just multiply 8 by 6 by 7, and that'll give you 336 packages. And the way to picture it is, let me get this PowerPoint up and see if this helps. Okay, the way to picture it is this. Let's do the slideshow. All right, so let's say, for example, you have 2 appetizers and 1 main dish. So we say 2 times 1, we say there's 2 combinations. So it would be 1 appetizer 1 and the main dish 1, and then you'd have appetizer 2 and the main dish 2. And those are two different combinations you can have. All right, so now when you add a second main dish to it, we have appetizer 1, appetizer 2. It's going to be 2 times 2, and you should have 4 combinations. So you had appetizer 1 with the main dish 1, appetizer 2 with main dish 1, appetizer 1 with main dish 2, and appetizer 2 with main dish 2. So what it is each of these elements, each appetizer, each thing that you are combining has to touch every one of the other ones. So that's why you have to multiply it. So I hope that helps. Let's look at that. All right. So what's the probability of rolling 2 dice and getting the sum of 5? Well, we know there's 36 possible combinations, right? There's 6 on dice 1 and 6 on dice 2. And so the total number of possible combinations is the total possible outcomes of the first dice, which is 6, and multiplied by the total number of outcomes in the second dice, which is 6, which is how we get 36 possible combinations. So there are 4 ways to get 5 on the 2 dice. There's a 1 and 4. You get a 1 on dice M and a 4 on dice N, a 4 on dice M and a 1 on dice N, a 2 on dice M and a 3 on dice N, and a 3 on dice M and a 2 on dice N. So do you see the combinations there? So the probability of rolling 2 dice and getting a sum of 5. Well, there's 4 ways to get 5. So of 36 possible combinations, there's 4 ways to get 5. So the answer is the probability is 4 over 36. All right, number 3. After recording the forecast of your local weatherman for 30 days, you conclude he gave correct forecasts 12 times. And we want to know, based on our empirical, on our observation, what is the probability his next forecast will be correct? So the probability is equal to what our empirical or what our observation was, which is he's correct 12 out of 30 times, which is 4 out of 10, which is 40%. So 40% of the time he is correct. Number 4, what's the probability of 76% free throw shooter will miss his next free throw? Okay, well, he's got to either miss it or he's got to get the next one. So we know that the probability of his getting his next free throw is 76%. So we want to figure out what's left. If 76 out of 100 times he gets his free throw, then how many free throws is he missing? So there's a 100% probability that he's going to do either one. We subtract the number of free throws the percentage of free throws that he actually makes, and that leaves us what's left, the ones he misses. It's either they miss it or they make it. So 76%, you subtract that from 100, and that'll give you a 24% chance that he will miss his next free throw. Okay, number 5. Some people had trouble with number 5. Actually, not too many. Let's read it. Suppose event A has a 0.99 probability of occurring. So 99% of occurring. Event B has a 96% probability of occurring. But odds are not the same as the probability something happened, because odds are stated as the ratio of the probability that the event will occur against the probability that it will not occur. So see there that formula? The odds of A happening is equal to the probability that A will happen divided by the probability that A will not. So we want you to compute the odds for event A and event B. And you see there with the formula, the probability that event A is going to happen, we already said, is 99%. That means the probability that it will not happen is 100% of the different events that can happen minus the 99 gives us 0.01. Gives us, well, here we're doing it as decimals. So the odds of A are 0.99 divided by 0.01, because this is how we defined odds. So it's 99 to 1 are the odds that this is going to happen. Okay. Now the odds of B happening the probability is 96. So we have to say 96 divided by the probability that it will not happen, which is 100 minus 96. That gives us 0.96 divided by 0.04, and it ends up the odds of B are 24 to 1. Okay, so that's how we calculate the odds. Notice that it's divided by, the probability is calculated, it says here, as chances for getting the event divided by the total number of chances. That's probability. It's over 100%, right? There's a 99% chance this will happen. There's a 50% chance this will happen. But odds are calculated by getting the event, the chance of the event happening, divided by the chances of it not happening. Okay? So probability uses total chances, and odds use probability of an event not happening as their denominator. And there's an example there. For example, if you draw, so there's 4 queens in a deck of 52 cards. So there's 7.69% chance that you're going to be able to draw a queen. That's a probability. The odds of drawing a queen is going to be the probability that it's going to happen, which is 4 out of 52, divided by the probability that it's not going to happen. So that would be 52 minus 4, which would leave us 48. So that equals 1 over 12. So the odds are 1 in 12 that you would pick a queen out of a deck of 52 cards. Okay, so the probability is 7.69, but the odds are 8.33. Okay, so let's go to the next one, number 6. What is the probability of discovering your 5 best friends all have telephone numbers ending in 1? All we care about is the last telephone number. We don't care, about any of the other numbers in front of it because we want the odds. The odds are dictated, or it's not the odds. The probability is dictated by that very last digit. We don't care what the combination is in front of it. All we care about is that last digit. Okay, so the probability of a single telephone number ending with 1 is 1. So how many numbers can we have? We have 0 to 10. So 1 out of 10 is a probability that that last digit is going to be 1. So what we want to do is calculate what's the probability of these five friends having this independent event of a 1 being their last number. All right. So it's a probability of events occurring together. They're and problems. I want to know the probability that Alice is going to have a 1, and Diana is going to have a 1, and Allegra is going to have a 1, and Grace is going to have a 1, and Sylvia is going to have a 1. They're ands. They have to all be together. When they're ands, the probability of ands are multiplied. All right. So the probability that the last digit is going to be 1 for 5 friends is 1 divided by 10 raised to the 5th power. And that equals 0.00001. You want to make it a percent, you can move that decimal over 2 digits to the right. You're multiplying it by 100. So 0.00001 multiplied by 100 is 0.001%. Very small probability. Okay. What's the probability of getting a sum of either 2, 3, or 4 on a roll of 2 dice? I have corrected the answer there because I didn't take it out from last time. All right. So what do we have to do to get a sum? Well, we have to get 1 and 1, or 1 and 2, or 2 and 1, or 2 and 2, or 3 and 1, or 1 and 3. And we do not do 1 and 1 twice, or 2 and 2 twice. They occur once, each dice having that 1 as a value of 2. So when we count those up, there are 1, 2, 3, 4, 5, 6 different ways that you can get 2, 3, or 4 on a roll of the dice. Now, there are 36 combinations. We already figured that out because there's a total number of possibilities of outcomes, which is 6 on one dice multiplied by 6 possible outcomes on the other dice, so equals 36. So we have 6 ways of getting a sum of 2, 3, or 4 over 36 possible things. So 6 of those possible things, 6 of the 36 meet our criteria. So when you divide that out, it ends up being 22.2%, or 6 over 36. Okay, number 8. Everyone pretty much got A and B right, and many people, probably except for those who, many people got the last one wrong. So let's go over this. Based on a historical record, what is the empirical probability that Miami will be hit by a hurricane next year? Well, this thing says, as studies show, question says, historically, Miami is hit by a hurricane every 40 years. So our observation, our empirical probability is 1 in 40. So the chance is 1 in 40. What is the probability that Miami will be hit by 2 hurricanes in 2 consecutive years? This is an issue of ands, right? This is the hurricane hits in year X and the hurricane hits in year X plus 1. The hurricane hits in 1 year and it hits in the next year. And they both have to occur. Whenever you have an and, it has to get smaller. The probability gets smaller because it's a tighter constraint. So the probability that Miami will be hit in 2 years is equal to the probability to 2 consecutive years. The probability that Miami will be hit in 1 year multiplied by the probability that Miami will be hit in 1 year. We know the probability is 1 in 40, so we multiply 1 over 40 times 1 over 40. That equals 1 over 1600, which multiplies out to 0.00063. When you multiply that by 100, the probability that Miami will be hit 2 consecutive years by a hurricane is 0.06%. It's common sense. It has to be less than the probability that it will happen in 1 year. You're multiplying fractions, therefore it gets smaller. Ands are always multiplication. C, our friend C. There's a formula for this, guys. What's the probability Miami be hit by at least 1 hurricane in the next 10 years? Okay, so there's a formula. And the formula is when you try to make sense of it from a logic point of view, I can't really explain it. So what you do is you just use the formula. It equals 1 minus the probability that Miami will not be hit by a hurricane raised to the number of years we're interested in, which is 10. So the probability that Miami will not be hit by a hurricane is 100 minus the probability that it will. Okay, so here I have it. So you have 1, which is 40 over 40. So that's all the possible years we can have in this. Over 40 years, we're going to subtract the probability that it will be hit, which is 1 over 40 years. And that gives us 39 over 40. The probability that Miami will not be hit by a hurricane is 39 over 40. So when we want to calculate how it will be hit by at least 1 in the next 10 years, we take 1 and subtract the probability it will not be hit, 39 divided by 40, raised to the number of years we're interested in, which is 10. If we were interested in the next 4 years, then it would be 39 over 40 raised to 4. Is that 1 over 4? I don't know how some of the numbers are coming up on this. So 1 minus 39 over 40, which is 0.975, raised to 10, which equals 1 minus 0.776. That equals 0.224. Multiply that by 100, and the probability that Miami is going to get hit by at least 1 hurricane in the next 10 years is 22.4%. Logic check. Very common logic check, very easy to do. It should, use your head. The probability to be hit at least once in 10 years is going to be bigger than the probability is happening in any given year, and that any probability of getting hit in consecutive years is going to be less than the probability to be hit in 1 year. It's common sense. Think about it. So that's the answer for that. Let's look at number 9, which I believe is not our last one. Okay, so we have an insurance policy. It sells for $1,000. This is this expected value problem. We have to find all the events. Okay. Well, the first event, anytime you see money in here, expect it to be an event. Okay. So first thing I do is I look at insurance policy sells for $1,000. There's my first event, and I paid per policy. The value is 1,000. The probability is 100% because if you don't pay, you don't play. You can't be having an insurance policy. So you get expected value for that is $1,000 times 100% probability because it's got to happen for this to happen at all. So expected value then is 1,000. Then we got to find where's the next thing that has the money on it. So based on the past data, average of 1 in 100 policyholders will file a $20,000 claim. Here's another event. The event is a $20,000 claim. The value of that is $20,000. And we say here that 1 in 100 people will file for that. So the probability of this happening is 1 in 100. So we multiply 20,000 times 1 over 100, and that gives us 200. And the reason it's negative, these parentheses mean it's negative. The reason it's negative is because it's something we pay out. This 1,000 we got in. So we have a $50,000 claim. Let's see there. So we've passed the 20, average of 1 in 200 policyholders. That's our next probability. And here's our next event, $50,000. $50,000, and we have 1 in 200. Multiply 50,000 times 1 in 200, you get 250. It's negative again because we pay that out. Okay, so now we have the average of 1 in 500. File $100,000. Here's my next event. And I put it down here as an event. The value is 100,000. The probability, as it says here, is 1 in 500. So when I multiply 1 over 500 by 100,000, I get expected value of 200. It's negative because I'm paying it out. Now, to get the total expected value per policy, I have to add this all up. So $1,000 is what I'm taking in, and I'm giving out 200, 250, and 200. So my expected value per policy is $350. So I have this helps me decide, is this enough? Do I need to have them pay more per policy? Because I don't want this to be nothing. It can't be negative, and I don't have to pay my business expenses. So this is how I decide this stuff. So I say here, if the company sells 100,000 policies, expected profits 350 times 100,000 or $35 million. And that's the answer for number 9. Okay, number 10. If you ask what the probability of this or that happening and the two events do overlap, then you calculate the probability as shown here. Probability of A or B happening when they overlap, so they're not independent. This is a different situation from our ORs, okay? Then equals the probability of A plus the probability of B minus the probability of A and B. And we know A and B is going to be multiplied, right? Because it's an AND. So the probability of drawing, so in other words, you calculate the probability of the first event, you add it to the probability of the second event, and then subtract the probability of both events happening. All right, because what we want is the probability that either one is going to happen or the other. That's why this is different. So probability of drawing either a king or a heart from a standard deck of 52 cards. Following the formula, probability of drawing a king is 4 out of 52, and that equals 7.7%. The probability of drawing a heart, there's 13 hearts in the deck, 13 over 52 is a 25% chance that you're going to draw a heart, which makes sense if you play cards, right? Because there's 4 suits, and hearts are one of them. So for that, what we want to calculate is the second part of this formula right here. We want to calculate this part, the probability of A and B. So we say the probability of drawing a king and the probability of drawing a heart, because it's an AND, we're going to multiply those two. 0.077, which is 7.7% times 25%, 0.25, equals 0.0193. Multiply that by 100. The probability of drawing a king and drawing a heart is 1.93%. The probability of drawing a king or drawing a heart, then we have to calculate it out. Probability of drawing a king, 0.77. Probability of drawing a heart, 0.25. Subtract the probability of drawing both. That equals 0.3077 multiplied by 100. That gives you 30.77%. So the probability of drawing either a king or a heart from a standard deck of 52 cards is 30.77%. Now that's how we do the solution for homework number 6. The biggest problem I saw, the most commonly occurring thing, was C. What's the probability that Miami will be hit by at least one hurricane in the next 10 years? Remember, it's just a formula. You just find the formula. You actually can even look at those cheat sheets, because those cheat sheets list out the formulas. So we want the probability that it will be hit by at least one hurricane. The formula for that is the probability. So the probability that something will not happen, will happen at least once, equals 1 minus the probability that it will not happen raised to the number of terms you're thinking about. So like years, or I think in our PowerPoints, the example was McDonald's, and we had the number of cups, the number of things you bought. So that's how we do homework 6. I did it as a YouTube, though I didn't have a whole lot to show you. And that's it. So enjoy, and please email me if you have any questions about this.